Hey, so near the end of the preparation phase of our bot manager. So really just cleaning some things up, doing some tuning. So for the joystick controller, I wanted it to start when I powered it on. So I had to convert the Joy node, the ROS2 node, into a service and then have Ubuntu fire up that service when I powered on Ubuntu. So now I just plug it in and it starts up. It takes a little time for that to start up, so I added an LED to the joystick controller as well, so I knew when the actual Joy node was active. The other thing I had to do was just clean up the Pico motor controller. I was getting some glitchiness when I changed the speed, when the joystick controller would change speed or resend the run command, even though it was the same command to go at the same velocity. There'd be some glitchiness, so I had to clean up the code there. Also did a little bit of general cleanup of the code there, so I showed that. And otherwise, that's about it. I just go through, show you the final checklist. I've closed that preparation one off, and then I've started planning for the next phase of this project, which is the actual robot build. And I got the box with the robot basin, the DFRobot Devastator. So I just have a quick look at that as well. One change I made to the joystick, or two changes I made to the joystick, was one to have it automatically start up the Joy node when I power it on. And because powering on takes a while, it's got to fire up Ubuntu and then fire up the Joy node as a service. When the Joy node starts up, it's now going to turn on the light, so we'll know it's connected. It takes about 47 seconds, I think I measured, to get through the boot and the start up of the Joy node as a service. There we go, lights on. So it's all started up, and I can see the twist messages arriving on my other Raspberry Pi, the one that's going to sit on the robot, generated from this. Then when I'm finished with it, I can just unplug it. So it makes it much easier to look after that, the joystick node. To add the LED to the joystick controller, I needed to install the Python 3 GPIO 0 library that allows me to control the GPIO for the Raspberry Pi. To get the LED to turn on when the Joy node starts up, I basically imported this GPIO 0 library, and then in the actual Joy node I created this property ROS run LED and set it to GPIO 13 on the Raspberry Pi header. Then during the init, when it reaches the init, it'll turn that ROS run LED on. So that's when it turns green on my joystick controller. And when the node ends, it just does a ROS run LED off to turn the LED off. So one thing I wanted to do was permanently set the permissions for the I2C interface, so I don't have to set it in Bash, and that would only apply for my current session. So this is how you set it up permanently. So first I did an export on my display so I can use X Windows, and then I did a sudo gedit, and the file I'm interested in is in the lib folder udev rules d, and this 60-I2C tools rules are the rules that will apply to my I2C interface. So let's run that. And we can see in here there's only one line for this rule. So it's basically saying for I2C dev devices, anything from I2C 0 to 9. And I've already set the mode here, so I changed it from 0660, where it wasn't having read-write access for everyone, to 0666, where everyone has access to I2C. So I don't need to save that, I already made the change. And if we do a less L on the dev I2 C1, I see because I already had that rule set, we've got read write available to everyone. Okay, for my joynode controller, because it's a separate box, I just want to be able to plug it into the power, have Ubuntu fire up, and then run the joynode. So the best way I found of doing that, I just looked on the web, is to convert the joynode into a service and then have that service enabled so it fires up when the Ubuntu fires up. So let's go through the process for doing that. So first I changed to the etc. systemd system folder. In there there's a whole bunch of system services already defined. So I wanted to create a new one for my joynode, so I did a touch joynode.service. Once I've created that, then I use gedit to edit that service, and let's have a look at what I put into that service definition. And by the way, all the commands and the content of these files I've put in the description below. The joynode service file made up of 3 main sections. So first is unit, which has a description, and I'll come back to the network part. The next is the service part, and this is where we define the service. So first thing, we need to set up all the environmental variables that are needed by the service, and basically we need the ones that are set by ROS. So you can do a print envir on and greep for ROS to get all those variables. We want to set the exec start, which is the command that you want to run in the service. Use the path to the ROS2 binary and then run the ourBotManager joynode. And finally, in this service section, set the user that you want to run under. Finally, you need the install section defined and the wanted by option. I'm not quite sure what this does, but this seems to be what you set it to. The other thing to look out for is in the unit section, you see I've got requires network manager wait online services, and after network manager wait on online service. I found I needed this to be able to have the node be able to send topic messages over the network. I could see them on the same Raspberry Pi machine, but I couldn't see them on my other Raspberry Pi machine that runs on the robot, because it wasn't routing the messages until I put this requires in the after statement to make sure the network manager was up and running when the node starts. Okay, we're all ready to go. To make sure the server starts up when the actual Raspberry Pi starts up, I'm going to use systemctl and enable the service joynode, and that'll cause it to be fired up when the Ubuntu fires up. So let's do that. What I'll do is ask for the password for Ubuntu. I'll ask for it twice. And now that service is enabled, so it'll fire up when Ubuntu starts up. There's some other system control messages that are useful. So systemctl status is useful to see what's happening. And here we get a rundown on telling me that joynode's running, what process it's running at, and also shows some of the output from the node. So that's useful for debugging. If you want to disable the service so it doesn't start up with Ubuntu, you can do a disable. I won't do it, but you can disable the joynode service. Some of the other options is to do a start if you just want to manually start joynode as a service, where you don't actually start it from the Ubuntu startup. And then finally, you've also got stop to stop the joynode service. So once I started using the joystick controller, I found I had a problem with the motor controller on the Pi Pico, where when it got another run command, even if it was for the same velocity, there'd kind of be a glitch on the motor while it rethought things and the speeds would change. So I thought I must have been doing something to reset things down on the Pi Pico MicroPython code. So what I found was in the run and in the turn commands, I was just re-enabling the interrupts for the motor encoders when another run or another turn came through. And I didn't really need to do that. The interrupts were already running for the encoders. So what I ended up doing, you can see the difference before and after, is I basically added a condition where if the motor mode, so if it's changing from run or to turn or from stop, then in that case the interrupts will have been disabled, so I need to turn them on again. But otherwise I don't need to do anything with either resetting the interrupts or any of the interrupt counters out there. And that seemed to solve all my glitchiness on the motors, at least until I get it into a real robot. Okay, I think I've finished preparation for our bot manager, so let's have a look at where we are. So this is the preparation checklist. I've actually marked it as done. You can see the items I've checked off here. The only things I didn't get done, and going to leave it until I actually build the robot now, is the lithium-ion battery hardware and software, and the mapping sensor. I'll also do that when I'm doing the build. But that one's closed off, and let's have a look at the new checklist I've created for the next phase of this project, which is the robot build. And I'll go over to the full view for this one. So again, this is phase 2 of our bot manager project, and this is where I actually build the robot base and the functionality for the robot. At the moment I'm planning on taking about 3 or 4 months to get through this, and the checklist items I've got for this is build the robot base, and I've decided to use the DFRobot Devastator robot base, which is a tracked robot for that, and I'll move all the processing and things that I put together during the preparation phase onto that base. I want to add a camera and a LiDAR sensor for the robot initially anyway. I'll probably put some sort of stand too for the LiDAR sensor, maybe for the camera as well, onto the base. And I'll use the LiDAR sensor to do room mapping. Next tasks here, I'm hopefully be able to use the ROS2 packages for doing mapping and navigation. So that's what I'll be doing in third and fourth tasks here. And I want to get it to a stage where I can drive the robot around, have it map my ground floor, so going through the kitchen and the living room and things, be able to put a map together using the ROS2 mapping capability, and then also add in the navigation functionality, so I can just tell the robot to go to a certain location and let it work out how to navigate there where I don't have to drive it. Next I want to add some battery recharging. This is the battery capability that I initially had in the preparation, so this is where I'll look at setting up the battery so it can recharge itself. I'll probably use a LiPo battery for this. That seems to be what they use in RC cars, and it'll be a good voltage for my robot. So I want to be able to have the ability to tell the robot to go back to a recharging station and recharge itself. After that, I want to add some robot reporting, so be able to report on its environment, so things like when it detects a cat, when it detects an object's move, so looking at its map and comparing the objects it sees with what's there, and that object detection will be a bit of computer vision work. I also want to report back just on the basic environment, so things like what's the current temperature, what's the humidity, air pressure, how much light have we got, battery status, those sort of things. And also report back on any activities, so when it goes and does some navigation, maybe just report back on the request and the result of that navigation. Next stage, add some robot tricks. I'm not sure what these are, but things like making sounds, maybe talking, maybe listening for instructions, maybe some sort of routine to play with the cat, and have some lights on the robot to be able to turn them on and off and do things like that. Then finally, it'll just be a cleanup task to tune the robot, finalize and plan for the final stage of this, which is the bit I was trying to get to is ourBotManager, where I have a cloud-based service that manages robots. This kind of be the new stuff for doing robotics. So once I've got my platform to put together for the robot that can do things, then I want to have a back end that can manage that robot and maybe other robots as well in a coordinated fashion. And they'll be kind of getting back into using Angular and Firebase backends to act as the cloud services for that. Hey, so I ordered the Devastator robot base. It just arrived, so this is the box it comes in. I'll actually do the build of the base in the next series of videos where I'm going through the whole robot build. But we're in good shape to start on that.